Hi guys, Mr. Sonnenberg here. Today we're going to be writing formulas for ionic compounds. This is for Science 9 students studying matter and chemical change, topic 6 in your textbook. Last time we talked about naming or writing formulas for molecular compounds. So now we're doing ionic compounds. So that's a metal and a non-metal in combination to form a compound. So topic 6 for study reference. So we have to look at a few procedures that we're going to follow. Remember last time when we were naming ionic compounds, we had to be familiar with the cation, which has a positive charge, which is plus, and the anion, which has a negative charge. So the cation, just some rules. So what we're going to do is we're going to write the formula for the cation and the anion. And then, what we're going to do is we're going to adjust the subscripts so that the charges cancel. So we might have to use the lowest common multiple, but we want a neutral charge. So, for example, if I had 2 plus on one side, I would want to have 2 negative on the other side. Or I could just have 2 negatives, which would change my subscript. Hopefully that's not too confusing. And then the last thing is really important right here. The cation comes first. And remember, cation is positive and it's going to be named first. So we're always going to name, and the cation is your metal or most metal-like when we're talking about polyatomics. Okay, so that's going to be important. Most metal-like because we might combine 2 polyatomic ions. So let's just go through a few examples here. The first example we're going to talk about is rubidium bromide. So what we have to do first here, and I'll write in a different color pen. What we have to do here is first we want to make sure we find the symbol and we find the ion and its charge. So the rubidium ion is going to be Rb plus, 1 plus. And we don't have to put the 1, we just put a plus. So now these are ions here, okay? So these are ions. Now the bromide ion is going to be Br negative. Now if you look at the element, if you were to look at this element on the periodic table, you'll see that it'll have a charge on it. Okay, so if you're looking at the element on the periodic table, you're going to see a charge. So that is its ion. So the bromide ion is negative. So how do we write this, folks? Well, we're actually going to write it Rb Br. Now we don't need any subscripts, and what we have here is we have a 1 plus charge and we have a 1 negative charge. So there's that neutral charge we were looking for. Okay, so we want to have a neutral charge, so they have to cancel each other out. The sum of cations, okay, so the cation and the sum of the anion have to be the same. They have to be the same, okay? Perfect. Let's try another one. I want you to pause the video this time, and I want you to see if you can name or if you can write the formula for calcium fluoride. Okay, hopefully you've had an opportunity to try this out. Let's see if your answer was correct. So the calcium fluoride ion, sorry, I said step away there for a second. The calcium fluoride, so calcium symbol is Ca, and its ion, the calcium ion, is going to be Ca2+. So that's right here, that's the calcium. The fluoride ion, okay, which is the anion. Now notice the trend here in the last two, and this is the cation. Notice the trend here that the cation is named first. Remember that rule. Now the fluoride is going to have the ion is going to be F minus. Now what we have to do is we have to take a look at the ion charge. So now, are these neutral? No, they're not neutral. So what do we have to do? Well, we're actually going to make sure there's enough fluoride ions to make sure the sum of calcium ions and the sum of fluoride ions are equivalent. So how am I going to write this? Well, I'm going to put Ca F2. Now that 2 down here, that 2 right here means that we need to add one more fluorine negative, because these two negatives right here would make 2. So that would make 2 negative. So we have to draw that down in our subscript. So CaF2, that is calcium fluoride's formula. Let's try another example. I want you to pause the video again and see if you can write this yourself. You might have to retrieve some of the polyatomic ions from your textbook as well. So what we have here is ammonium carbonate. So we have 2 polyatomics. So that's a polyatomic, and so is this one here as well. Okay, so they're both polyatomic ions. Okay, so those are naturally forming ions, but they stay in that form, and I want you to be familiar with these polyatomic ions. So first thing I'm going to do is I'm going to actually write out the symbol, okay, or the ion formula. So ammonium is NH4 plus, and carbonate is going to be CO3 2 minus. Now I don't need to look at the subscript number, which is down here where the mouse is pointing. I want to look at the ion charge up here. I want to look at these. Now, are they equivalent? No. So what do I need to do? Well, I need to add one more ammonium. I need one more. Why? Because I need the sum of ammonium, my cations, to be equivalent to the sum of my anion. So what I'm going to do here, how am I going to write that? Well, I'll just write it in green. I'm going to write NH4, okay, and then I'm going to write CO3. But what I need to do now is I need to add a subscript. So this is where parentheses come into play. I need to put parentheses, and then I need to add the subscript of 2. Where does that come from? Well, because I only had one positive charge here, and I need it to be equivalent with that 2 over here. Okay? Well, in order to do that, I have to add one more ammonium. So I've done that with this number down here. But the parentheses are really important. Parentheses, remember, are these brackets, because if I didn't put that, then this number right here would look like NH42. So that would be meaning that we have 42 hydrogens for every one nitrogen, and that's not right. So we have to put the parentheses showing that there are 2 of the ammonium ions. So that is how NH4 in parentheses with a subscript of 2, CO3. That's how we would write this ionic compound formula. And let's try one more. This one's a little bit harder. Now we pull into play the lowest common multiple. Lowest common multiple. Can't talk right now. So what we're going to do here is aluminum sulfate. So we have a metal, okay, and we have a polyatomic ion. So what is the aluminum ion? Well, it's going to be Al3+. Now notice I'm always writing the ion first. And what's sulfate? Well, sulfate's a polyatomic ion, so it'll be found on the list of polyatomic ions, and it's SO4, but its ion charge is 2 negative. So now what I have is I have a little bit of a problem here. I can't just add 2 sulfates, because that would give me 4 minus and 3 plus, and we're not equivalent. We're not neutral in charge. So what I need to do is I just need to write it out. So I'm going to write out Al, and then I'm going to write out SO4. Now what's the lowest common multiple of these? Well, the lowest common multiple of 3 and 2 is going to be 6. So I'm going to put a 6 negative over top of here, and I'm going to put a 6 positive over top of the aluminum. Aluminum is my cation. Okay, it's my cation. Sulfate is my anion. Okay, and so I have this 6 plus charge right here. So that's my lowest common multiple. Lowest common multiple here. I'll just write that in for you guys just to remind you. Common multiple. Oops, getting a little close. Okay, lowest common multiple. So now what I do, maybe I'll just write this AL out again. AlSO4. Okay, so what am I going to do now? I need to, with the lowest common multiple, what 6 divided by 3, or how many times do I multiply this 3 right here to get 6? Well, I multiply it 2 times, right? Times 2 is going to equal 6. So that means I have to put a subscript of 2 down here. But what I need to do now is I need to put in parentheses. Okay, and I'll write this out again after just to show you. So now what I need to do, what's the lowest common multiple here? So I have a charge of 2. That times what is going to equal 6? This is where it gets tricky. Well, 2 times 3 is going to equal 6. So now that means I have to put a subscript of 3 down here. So to write this out proper, I'm going to get AL2, okay, SO4 in parentheses 3. Okay, so that's going to be my formula for aluminum sulfate. So that's writing formulas for ionic compounds. I hope this has helped you guys. Please, if you have any questions, bring them to me. I'll gladly answer them and sit down with you folks. And remember to play, pause, rewind. That's the benefits of these screencasts, is that you can go back if you don't understand and you can make sense of it by just listening to it again. I don't want you guys to have questions and not ever get them answered because we just didn't have enough time or you didn't feel comfortable in front of your classmates. Play, pause, rewind, get those questions, bring them to me. Anyways, I hope this has helped, and thanks for tuning in, guys. We'll see you on the next one.